This is the 17th video and second video on shear stress and shear strain, and here I'm taking problems on shear stress and shear strain. Now the formulas used are for single shear stress, P is equal to pi by 4 d square, where d is the diameter of the rivet and P is the shear force. For double shear stress, P formula is double shear stress is equal to P divided by bracket open 2 into pi divided by 4 into d square bracket close. So for double shear we have to double the area because it fails in two failure planes. Then compressive force F in the punch is equal to shear force in the plate, and compressive force F in the punch is equal to sigma of punch into cross-sectional area of the punch, and shear force in the plate, that is equal to shear stress of the plate into thickness of the plate into circumference of the hole. Shear area for a circular punch is equal to pi d, which is the circumference of the hole, into thickness d. Shear area for a rectangular punch of size b d will be 2 into bracket b plus d into t. And if we want the diameter of the punch or diameter of the hole, then this formula can be directly used. D is equal to tau of the shear stress of the plate, tau into thickness of the plate into 4 divided by sigma of the compressive stress of the punch, sigma. That will give the diameter of the punch. Now let us take the first problem. A steel punch can be worked to a compressive stress of 850 megapascal. Find the least diameter of the hole which can be punched through a steel plate of 10 mm thick if its ultimate strength is 320 megapascal. Now, as we know, compressive force F in the punch is equal to shear force in the plate. The compressive force F in the punch is equal to sigma, that is the compressive stress in the punch, into cross-sectional area of the punch, is equal to shear stress of the plate, tau, into thickness of the plate into circumference of the hole. If we substitute the value, then it is stress in the punch given is compressive stress is 850. Area of the punch will be pi divided by 4 into d square. D we have to find out. Shear stress, the ultimate shear stress, is given as of the plate 320. Thickness of the plate given is 10 mm, so that is 10 mm, and circumference of the hole will be pi d. Here pi d on the left side and the right side, it gets cancelled, and then what remains is d is equal to, now this is tau t into thickness, and this 4, when it comes here, it becomes into 4, and this is sigma stress, compressive stress, it gets divided. This is the formula. So here 850 divided by 4 into d, pi d gets cancelled. Here pi d gets cancelled, so what remains is 320 into 10. So d will be equal to, if I want to calculate d, what I have to do is 320 into 10, and this 4, when it comes here, into 4 divided by 850. Once again, take the calculators in your hand and do the calculations. Start from here. 320 into 10 into 4 divided by 850. That will give you the diameter 15.06 mm. Or now here I am substituting sigma punch as sigma, area as pi by 4 d square, and tau plate as tau, thickness of the plate t as t, and circumference of hole as pi d. So when this pi d gets cancelled, here on this side it is sigma divided by 4 into d. 1 pi and this pi and 1 d will get cancelled. Here pi d gets cancelled, so on this side it is only tau into t. So d will be equal to tau of the plate into thickness of the plate into 4 divided by compressive stress of the punch, sigma. Substitute a value. Tau is 320. This is the shear stress. So tau 320, thickness of the plate 10 into 4, and sigma, the compressive stress sigma, is 850. So 320 into 10 into 4 divided by 850. We can use directly this formula, substitute values, and you get the answer. The button is to be placed on the calculator that I am giving here. Buttons on the calculator, 320 into 10 into 4 divided by 850, it will give you the answer 15.06. You can write out this is a very simple calculation. 320 into 10 into 4 divided by 850 is equal to, and you will get the answer. The least diameter of the hole D is equal to 15.06 mm. Let us come to the question. Calculate a force required to punch a hole of 30 mm diameter in a metal of thickness 20 mm. Permissible shear stress in a material and corresponding factor of safety is 400 MPa and 3 respectively. Now permissible shear stress is given, but when the hole is punched, at that time it is the ultimate stress and it is not the permissible stress. So we have to calculate the ultimate stress. So now while punching the hole, the shear stress will be the ultimate stress. So sigma ultimate will be factor of safety into permissible stress. So 400 is the permissible stress, factor of safety is 3. So 3 into 400, that will give us 1200 megapascal. And this is the maximum stress, and that we will take it as the shear stress in the punch. Now shear force required for punching will be tau of the plate into thickness of the plate into circumference of the hole. Now tau of the plate we have to take 1200. This is a very important step. Here we cannot take it as 400 because it is a permissible stress and not the ultimate stress. So 1200, thickness of the plate given here is 20 mm, so 20, and the hole diameter is given as 30 mm. So the circumference will be pi d, that is 30. Multiply it here, 1200 into 20 into shift pi into 30. You will get this answer. You will get the answer here 2.26 into 10 raised to 6 Newton or 2261.95 kilo Newton. So this is the force required to punch a hole of 30 mm diameter. So this is the answer P. Let us take a next problem. A steel punch can be worked to a compressive stress of 800 MPa. Find the least diameter of the hole which can be punched through a steel plate of 12 mm thick if its ultimate strength is 315 megapascal. Now this is the same problem as it was before. Here we want the least diameter, so directly use the formula. This is the compressive force in the punch is equal to shear force. This is the same. 800 is the stress in the punch, area of punch pi by 4 d square. Then shear stress is of the plate will be 315, thickness of the plate 12, circumference of the hole pi d. So compressive force in the punch is equal to shear force. Pi d gets cancelled, so 800 divided by 4 into d on the right hand side, and here pi d gets cancelled, so it will be 315 into 12, and if you calculate d, 315 into 12 into 4 divided by 800, 315 into 12, this 4 here will become into this 800 on this side. When it comes, it will become divided by 800. That will give you d is equal to 18.9 mm. And if you can directly remember the formula, d is equal to shear stress in the plate into thickness of the plate into 4 divided by compressive stress of the punch. Substitute the value. The shear stress is 315, thickness of the plate is 12 into 4, and compressive stress of the punch is 800, so divided by 800. So 315 into 12 into 4 divided by 800, that will give you the diameter 18.9 mm. The buttons to be pressed on the calculator, same, 315 into 12 into 4 divided by 800 is equal to, you will get the answer 18.9 mm. The questions on the shear stress are usually easy and it can be solved very easily. Only one formula you have to remember. A steel punch of 15 mm diameter is used to make a hole of 5 mm thickness. If shear strength of the plate is 80 megapascal, calculate the force required to punch the hole. Now shear strength is given, so again the same formula: compressive force F in the punch is equal to shear force in the plate, and compressive force is equal to sigma punch into area of punch, and shear force is equal to tau plate into shear stress in the plate into thickness of the plate into circumference of the hole. Now F will be equal to, now we will use this because these things are given. Shear stress given is 80, this is the shear strength, that is the shear stress 80. Then thickness given is 5 mm, so T will be 5. Diameter given is 15, so pi into 15 pi d, that is the circumference of the hole. And when you when you multiply 80 into 5 into pi into 15, that will give you the force F. So F is equal to 80 into 5 into shift pi into 15 is equal to, you will get the answer 18.85 into 10 raised to 3 Newton. It means 18.85 kilonewton. This is a very simple calculation, so you can very easily do these calculations and solve the problem. Next question: a 12 mm diameter MS bar, when tested for single shear, carries a load of 8.16 kilonewton. Determine the shear stress induced. Here also the formula is very simple. I am using a symbol Q for shear stress. So shear stress is equal to shear force divided by the shear area A. Now the Q is equal to, now the shear force is, it carries a load 8.16 kilonewton, so that will be the shear force, and convert it into Newton. So 8.16 into 1000, it will make 8.16 in Newton divided by area. Now diameter given is 12 mm, so divided by bracket open pi by 4 into 12 square, that bracket close, this will be the area. Take the calculators in your hand, start pressing the button from here. 8.16, and you can directly do exponential 3 divided by bracket open shift pi divided by 4 into 12. Press x square button, bracket close, is equal to, it's a very simple calculation, and you will get the answer 72.15, and unit will be Newton per mm square. This force we have converted in Newton, and 12 mm is the diameter, so area is in mm square. So shear stress is equal to 17.15 Newton per mm square. Now this is the next problem. A circular pin of 12 mm diameter carries a force of 12 kilonewton in double shear. Determine the shear stress induced. Now the shear stress induced will be shear force F divided by, now it is in double shear, so we have to double the area twice A. This is very important here. If you by chance take single A, then the answer will go wrong, because in double shear there are two failure planes, and that is why we have to double the area. So Q is equal to, now shear force given is 12 kilonewton, so 12 into 1000, that will make the force in Newton divided by bracket open 2 into, now area 12 mm pin, so the diameter is 12 mm, so pi by 4 into 12 square, bracket close, and put the bracket in the denominator so that your answer doesn't go wrong. Now take the calculators in your hand and start pressing the button from here. 1 2 into 1 0 0 0 divided by bracket open 2 into shift pi divided by 4 into 1 2 x square, bracket close, is equal to, and you will get this answer 53.05, and unit will be Newton per mm square. So if it is a single shear, you have to take the area only once, but if it is given that it is in double shear, then don't forget to make the area twice. This is very important. Otherwise the problem is very simple. Now let us take a next problem. Two plates 100 mm wide and 10 mm thick are joined by two rivets of 16 mm diameter as shown in figure. Determine the stress induced in each rivet. Now here there are two rivets. From the top, if we see, there are two rivets, and in the cross section we can see it like this. In the cross section we'll see only one rivet, and a tensile force of 8 kilonewton is acting here on the plates, and the same 8 will act as a shear force for the rivet. Now this 8 kilonewton force which is on the plate will be shared by both the plates. So force in each rivet F will be equal to P divided by 2, that is P is 8 divided by 2 is equal to 4 kilonewton. So each rivet will have a force 4 kilonewton. So the shear stress in each rivet Q will be F divided by A. Now the force in each rivet is 4 kilonewton, that is 4000 divided by, now the diameter of the rivet given is 16. So area will be pi divided by 4 into 16 square, and put the bracket in the denominator. And now do the calculations from here. 4000 divided by bracket open shift pi divided by 4 into 1 6 x square button bracket close is equal to, see, you will get this answer 19.89 Newton per mm square. The calculations are very simple. Here only thing is, if they are giving two rivets, don't forget to divide the force by 2. This 8 kilonewton force will be shared by two rivets, so force in each rivet is 4 kilonewton, and that is what you have to take here. By mistake, if you take it as 8000, your answer will go wrong. Now here is one assignment I am giving. This is the 8th assignment. Question number 1. A steel punch can be worked to a compressive force of 800 Newton per mm square. Find the least diameter of the hole which can be punched through a steel plate of 10 mm thick if the ultimate shear stress of the plate is 300 Newton per mm square. Answer is 15 mm. You can use this formula. A circular hole of diameter 20 mm is subjected to a, a circular hole of diameter 20 mm is to be punched through a plate of 10 mm thick. Find the force required to punch a hole if shear stress of material is 250 Newton per mm square. Hence find the compressive stress developed in the punch material. And the answers here I am giving it. F is equal to 157.079 kilonewton and compressive stress is 500. Calculate it, try it, whether you get the same answer. Question number 3. Determine the smallest size of hole that can be punched in 12 mm thick MS plate having ultimate shear stress of 390 Newton per mm square if the permissible crushing stress for the punch material is 2.4 kilonewton per mm square, and the answer is D is equal to 7.8 mm. Question number 4. A force of 31.68 kilonewton is required to punch a circular hole of 14 mm diameter in a metal plate of 2 mm thickness. Calculate the ultimate shear stress and compressive stress developed in the punching rod. The answer is shear stress is equal to 360.14 Newton per mm square. Compressive stress is 205.8 Newton per mm square. Question number 5. A rectangular hole of 8 mm by 10 mm is to be made through a plate 2 mm thick. Find the force required to punch the hole. Shear strength of the plate material is 300 Newton per mm square. Also find the compressive stress developed in punching. F is equal to 21.6 kilonewton. Compressive stress is 270 Newton per mm square. See whether you are getting this answer. And this is a rectangular hole, so here perimeter will be 2 into bracket B plus D, and area for the compressive stress, area will be B into D, that is 8 into 10. Be a master. Thank you.